On a graph, we're asked to shade the region that satisfies the following inequalities. So with the first one, we're asked, or we're told that x is greater than -1. So we know that we will be using a dashed line to represent this particular straight line. So we can draw that. It's going to be a vertical line at x equals -1 and shaded to the right of the line. Now with the second inequality we have y is greater than or equal to 2x, so we know we're going to have a solid line, and this is the equation of a straight line where the gradient is 2 and the y-intercept is 0. So we know it's going to start at the origin, and for every 1 we go across we need to go up by 2. That's our rise and that's our run. So that's a solid line, so we can draw it like this. So that is x is greater than -1. This is y is greater than or equal to 2x. Now, it's greater than or equal to 2x means all the values above the line. So we shade that part in. Now for the third inequality, y is less than or equal to 5, so we know it's going to be a solid line again, and it's going to be a horizontal line at 5. And it's less than or equal to 5, so we can shade below. And that is y is less than or equal to 5. Now for the fourth inequality, y is greater than 2. So this is going to be a dashed line. There's no equals there. So we go to 2 and we draw a horizontal line, and we know it's going to be dashed. And we know it's greater than, so we shade above the line. Now for the final inequality, this is actually the equation of a straight line. It could be written as y is equal to -1x plus 6. So here my m value is -1, that's my gradient, and that's a downhill or down slope, negative slope. And this is my plus c, so that's my y-intercept, so that's +6. So we know it's going to cut the y-intercept at 6. And because its m value is -1, for every 1 we go across, we're going to go down or drop by 1. So it's less than, but there's no equal sign there, so we know this is going to be a dashed line. So we draw it like thus. And that is y is less than 6 minus x. And the less than just means everything below the line. Now, when we combine all of these inequalities and look at the overlapping regions, we discover that we have a particular shape that is bound by all of those lines and that satisfies this particular area, and that happens to be that region there.